Now, you got two functions, f and g. You know what f of 2 is, correct? F of 2 is what? 4 times 2, subtract 1. 8 minus 1, which is 7. If I asked you, what is f of x plus g of x? You would just substitute, right? 4x minus 1 plus 2x minus 3. And I would put these in parentheses. Just in the event, if there's a subtraction sign there, you'll distribute correctly. Now we see that we can combine the like terms, and we get 6x minus 4. What about f of x times g of x? Wouldn't we just put them next to each other and multiply? And we get 8x, 8x squared minus 12x minus 2x plus 3. Combine my like terms. 8x squared minus 14x plus 3 for a final answer. Everybody okay with that? So, where do I start when I nest these functions inside each other as a composition? You start with k, and where are you going to put k? Into g. Very good. So I've got f of 2x squared minus 3. Now what do I do with that? Put the 2x squared minus 3 into f. So that's 4 times 2x squared minus 3 minus 1. Now what? Distribute. 8x squared minus 12 minus 1. 8x squared minus 13. F of x equals 3x minus 2. What's the domain of that function? It's all real numbers, isn't it? This is a linear function. Its domain is always all real numbers. What about f of x equals 2x squared minus x plus 3? Why? Why is that all real numbers? Exactly. This is a polynomial function. Just like with a linear function. It'll always be all real numbers. Remember, you only have two operations that have restricted domains. And that is rational functions with variables in the denominator. And second, square root function. These are the two functions that we've got restricted domains on. Everything else we've learned have been all real numbers. Find the domain. Do we have any problems on the top of our fraction? No. That's just a linear function. It's fine. Let's just look at the denominator itself. Does it have any restrictions? No, it doesn't. The denominator by itself is a linear function, correct? So that's telling me that part itself is all real numbers. just like the top was, all by itself. Now, when I apply this to the entire function, now f of x is a numerator with a denominator that's got a variable, correct? And what do we know about that? The denominator of any fraction, I don't care what it looks like, can never equal 0. So 3x plus 7 is not allowed to equal 0. I solve for x. 3x cannot equal negative 7. Therefore, x cannot equal negative 7/3. That's the only number in the world that x can't be. It is not allowed to be negative 7/3. And we'll clean that up. Do square roots have issues? Is there domain issues?
No.
You can square root every number.
No.
No, you can't. What numbers can't you square root? You cannot square root negative numbers. So, a square root function has a restricted domain. And here's what we said. The radicand has to always be greater than or equal to 0. And the radicand is always underneath the radical. So if I'm talking about a square root, that radicand always has to be larger or equal to 0. So when I look at g of x, which is square root of 3x minus 1, 3x minus 1 has to stay greater than or equal to 0. So I solved that inequality. 3x is greater than or equal to 1. When I divide by 3, x is greater than or equal to 1/3. That is my domain.